Welcome everyone. I'm Lucy from Entra Innovations. Today we'll explore the exciting world of open source FPGA tools and methodologies.
Lucy, before we dive into open source tools, can you remind us what FPGAs are and why they're special?
Great question, Sneha. FPGAs are field-programmable gate arrays, essentially hardware circuits that can be reconfigured after manufacturing. Think of them as digital clay that you can reshape for different applications.
I've heard that traditional FPGA tools are really expensive. What problems do they create for developers and researchers?
Exactly right, Arjun. Proprietary tools create expensive license fees, vendor lock-in, and restrict innovation. They're like closed boxes. You can't see inside or modify them for your specific needs. Open source tools solve these problems by eliminating licensing costs, fostering collaboration between academia and industry, and providing complete transparency for security and customization.
This sounds amazing. What are the main open source FPGA tools we should know about?
Cornerstone is the VTR framework, Verilog to routing. Developed at University of Toronto, it transforms Verilog HDL code into optimized FPGA implementations through a complete toolchain. VTR handles the entire flow: front-end HDL processing, technology mapping, placement and routing algorithms, and timing analysis. Watch how it transforms your design step by step.
That's impressive. But do these open source tools work well together, or do you need to manually connect everything?
Excellent question. VTR integrates smoothly with other tools like Yosis and ABC. This creates a seamless flow from RTL design to detailed FPGA mapping, leveraging each tool's strengths. Now let's explore OpenFPGA, a DARPA-funded framework from University of Utah. It's designed for rapid prototyping of customizable FPGA architectures.
Wait, did you say we can design custom FPGA architectures? That sounds incredibly complex. How does OpenFPGA make that possible?
OpenFPGA features two interconnected workflows. The production flow lets architects design custom FPGA fabrics, while the end-user flow allows developers to target these architectures. It's like having both the factory and the application tools. The third key tool is Yosis, the Open Synthesis Suite. It handles nearly all Verilog 2005 features and integrates formal verification methods to ensure your designs are correct.
Yosis sounds powerful. What are some practical ways we can use it in real projects?
Yosis excels in RTL synthesis for production, pre-production testing, Verilog format conversion, algorithm demonstrations for teaching, and custom research flows. It's incredibly versatile. OpenFPGA's advanced features include XML-based architecture descriptions that are human-readable and highly customizable. This enables precise specification and research into novel FPGA concepts.
With all these new tools, how do we benchmark and validate that our designs are working correctly and efficiently?
Great question. Koyos 2.0 provides a comprehensive suite of deep learning benchmarks specifically designed for realistic evaluation of CAD algorithms and FPGA architectures. Watch how it tests different configurations.
This is all fascinating. For someone just starting with open source FPGA tools, what would you recommend as the best learning path?
I recommend starting with Yosis for synthesis basics, then moving to VTR for complete flows, and finally exploring OpenFPGA for custom architectures. Build your skills progressively. The future looks bright. Open source FPGA tools are rapidly growing, fostering innovation and making FPGA development accessible to everyone. The community is driving incredible advances. To summarize, open-source FPGA tools like VTR, OpenFPGA, and Yosis offer unmatched flexibility, cost savings, and customization. They foster innovation, collaborative improvement, and make FPGA development accessible to everyone.